A flash of impossible color rips across the night sky, blooming into a perfect sphere of shimmering light before it vanishes. It's a moment of pure magic, a fleeting spectacle that delights millions. But that brilliant burst, that thunderous boom that echoes in your chest, is the final act in a long and perilous story. A story that begins not in the sky, but on the factory floor with nothing more than simple, raw dust. How do you turn this, a pile of basic chemical powders, into this, a celestial explosion of perfectly choreographed light and sound? The journey from one to the other is a hidden world of controlled violence, a delicate dance between chemistry and pure craftsmanship. We're going inside one of the world's largest fireworks factories to reveal the complete end-to-end process. From the volatile mixing rooms where colors are born, to the hand assembly of explosive shells and the final, fiery tests that prove they're worthy of the sky. This is how magic is manufactured. Chapter 1. The Heart of the Factory. The chemical compound. It all starts where the firework gets its soul, the chemical compounding area. But forget any image of a dusty workshop. A modern fireworks mega factory is a sprawling campus of separated, reinforced buildings, all designed for one thing: safety. The most critical work happens in small, isolated bunkers, often built with a weak wall designed to direct an accidental explosion away from everyone and everything else. Inside, it feels more like a laboratory. The air is clean, surfaces are smooth, and every tool is made from non-sparking materials like brass or bronze. Technicians in fire-resistant clothing and anti-static boots move with a deliberate calm. They aren't just workers, they're pyrotechnic chefs, following recipes tested thousands of times. The foundation of nearly every firework is a recipe that's over 1,000 years old. Black powder. It's the engine of pyrotechnics, used to both launch the firework and to burst it open. The classic formula is a precise mix, usually 75% potassium nitrate, 15% charcoal, and 10% sulfur. Each ingredient is critical. Potassium nitrate is the oxidizer. It carries its own oxygen supply, so the firework can burn anywhere, even in the thin upper air. Charcoal is the fuel, and sulfur acts as a stabilizer, lowering the ignition temperature and speeding up the reaction. These ingredients are weighed with obsessive precision, then mixed for hours in industrial ball mills, huge rotating drums filled with non-sparking lead or ceramic balls. This isn't just mixing. It's about creating a perfectly homogeneous blend, ensuring a reliable and predictable burn every single time. But a firework that only goes bang is no fun. The real art is in the color. This is where chemistry becomes a painter's palette. Vibrant hues are created by adding different metal salts to the mix. When these salts get superheated, their atoms absorb energy. And as they cool, they release that energy as light. The specific element determines the color we see. Want a passionate, deep red? You need strontium salts. For a brilliant, electric green, it's barium compounds. And those bright, piercing yellows come from sodium salts. But the real test of a pyrotechnician, their holy grail, is the color blue. It is notoriously difficult to create. The color comes from copper compounds, but at the extreme temperatures of a firework burst, they tend to break down and wash out the color. A perfect blue requires a cooler burning, carefully balanced formula to protect the copper compound just long enough for it to shine. Of course, you can mix these to get a whole spectrum. A brilliant purple, for instance, is a masterful blend of red-producing strontium and blue-producing copper compounds. Dazzling whites and silvers are made with powdered metals like magnesium, aluminum, and titanium. Special effects like crackling dragon eggs use bismuth or magnesium. Alloys, while glittering brocade effects use special charcoal and metal flakes that smolder long after the burst. Once the recipe is perfect, a final ingredient is added, a binder, usually a simple starch like dextrin mixed with water. This transforms the loose powder into a thick, damp dough. This pyro dough is now stable enough to handle and ready for the next stage, becoming a star. Chapter 2. Forging the stars. The soul of the firework. Those brilliant points of light in the sky are called stars, and this is where they're born. The name is poetic, sure, but making them is a masterpiece of industrial mechanics and patient craft. There are two main ways to do it: cutting and rolling. The cut star method is for speed and uniformity. The damp pyro dough is rolled into flat sheets and then diced by a machine into thousands of tiny, identical cubes. These little stars are perfect for effects that need a dense, uniform cloud of color, like a classic peony burst. They're then dusted with a fine layer of black powder, which acts as a primer so they all ignite at the same time. The second method, rolled stars, is more complex and reserved for larger, high-end fireworks. The process is a lot like how confectioners make jawbreakers. It starts with a tiny core, like a rapeseed, placed inside a large, rotating drum. As the drum spins, a technician ladles in a slurry of the pyrotechnic chemicals. The cores tumble and pick up a thin, even layer. This is repeated over and over, sometimes for days, as the stars slowly grow, layer by painstaking layer. The real artistry here is creating color-changing effects. A technician can start with a blue composition, add several layers, then switch to a red one. When that star burns, it will start blue, then magically transform into red. The most complex shells can have stars with 4 or 5 color changes, all built right here. Whether cut or rolled, the new stars are wet and unstable. They're carefully spread onto wooden trays and moved into climate-controlled drying rooms for several days. This drying stage is non-negotiable. It removes every trace of moisture, ensuring the stars ignite properly and burn at the correct speed. Only when they are rock-hard and bone-dry are they ready for the main event, assembling the aerial shell. Chapter 3. Building the shell. The vessel of light. Okay, now it's time to put all the pieces together. The assembly floor is a place of incredible precision, where much of the work is still done by hand, a craft passed down through generations. The container for all this explosive art is the aerial shell. And for those magnificent, perfectly spherical bursts, the shell is made from, well, paper. Lots and lots of paper. Workers paste layer after layer of durable craft paper over a spherical mold, building up a hollow hemisphere. After dozens of layers, the paper shell is incredibly strong. Now, the real work begins. An assembler first places the time fuse. This is a special cord designed to burn at a very precise rate. The length is calculated perfectly because it determines the exact moment the firework bursts. The goal is to have it go off at the very peak of its flight to create the biggest, most symmetrical display. Next, the stars are carefully placed inside, and the placement isn't random. It dictates the final pattern in the sky. For a classic round peony burst, the stars are mixed loosely. For more complex patterns, like hearts or smiley faces, the stars are painstakingly glued onto a paper scaffold inside the shell to hold their shape. Once the stars are in, the very center of the shell is filled with the bursting charge, typically a coarse black powder. This is what will shatter the paper casing and hurl the stars outward at hundreds of miles per hour, painting the pattern across the night sky. Too little charge, you get a weak, disappointing burst. Too much, and it can actually shatter the stars before they even ignite. The two paper hemispheres are then joined, and the whole sphere is wrapped in even more layers of pasted paper. A single 12-inch shell might get over 100 layers, applied one strip at a time. This wrapping contains the immense pressure of the burst just long enough to ensure a powerful, symmetrical explosion. Finally, the shell is attached to its engine, the lift charge. This is a bag of granulated black powder fixed to the bottom. When ignited inside a mortar tube, it's the massive gas expansion that launches the shell skyward, all while the time fuse is patiently burning its way toward the center. Chapter 4. The final hurdles, curing and quality control. The assembled shell is complete, but it's heavy with moisture from all that paper and paste. Now it enters the longest phase of production, curing. The shells are moved into large, fortified drying buildings where they will sit on racks in a temperature and humidity-controlled environment for weeks, sometimes even months for the biggest ones. This slow, patient process is critical. It allows the paper casing to harden into a vessel as strong as wood and ensures the powders burn with maximum power. After their long wait, the shells are ready for the most important stage, quality control. The factory's reputation and public safety depend on every shell performing exactly as designed. First, physical checks. Each shell is weighed. If it's off by just a few grams, that's a red flag for a catastrophic failure. Calipers measure its diameter to ensure a perfect fit in the mortar tube. Too tight and it could get stuck and explode on the ground, a devastating flower pot. Too loose and it won't launch high enough. But no physical inspection can replace the ultimate test. A random sample from every single batch is taken to the proving ground. This is a remote test range where technicians can observe safely from concrete bunkers. One by one, shells are loaded into steel mortars. High-speed cameras, Doppler radar, and sound level meters are all aimed at the sky. A technician gives the command. With a deep thump, the shell streaks upward. Everyone watches, not for the beauty, but for the data. Did the time fuse burn for the correct number of seconds? Did the shell reach its designed altitude? Then, the burst. Is the pattern a perfect sphere? Is the color vibrant and true? If even one thing is off, the test is a failure. The entire batch is quarantined, and an investigation begins to find the error. The stakes are just too high. Only when a batch passes this fiery trial is it certified and ready to ship. Chapter 5. From factory to festival, the final journey. Once certified, a batch moves to packaging. This isn't like boxing up t-shirts. Fireworks are hazardous materials, and their packaging is governed by strict international regulations. The shells are placed into heavy-duty cardboard cartons with anti-static liners. Each box is clearly labeled, with bold warnings and, crucially, a batch number. This traceability is essential. If a problem is ever discovered in the field, that number allows the manufacturer to instantly trace it back to the exact production line and date it was made. The sealed cartons are loaded onto special trucks operated by drivers with hazmat certifications. The fireworks travel to secure, climate-controlled magazines around the world, awaiting their final destination. That journey ends in the hands of a licensed pyrotechnician, the artist who will weave these creations into a show. When they design a display synchronized to music, they are trusting the factory's obsession with precision. They need to know that when the computer says fire, a 6-inch red peony will launch to its exact altitude and burst at the exact moment. The factory's hard work is what makes their art possible. From a handful of colored dust, through the violent crush of mixing mills and the patient layering of the star rollers. From the skilled hands that pack each shell with artistic intent, to the long, silent weeks in the curing vaults and the final, thunderous judgment of the proving ground. The creation of a firework is an incredible journey of transformation. It's a process that marries ancient chemistry with modern engineering, where precision is a matter of life and death. Behind every single burst of light that fills the sky, there are hundreds of quality checks and the quiet dedication of countless skilled technicians. So the next time you're standing with your head tilted back and you feel that primal thrill as a shell screams upward and explodes into a perfect, shimmering chrysanthemum, remember the journey it took. You'll know you're not just watching an explosion, you're witnessing the glorious finale of science, artistry, and a tremendous amount of controlled power. You'll know how the world's mega factories turn dust into pure wonder. What's the most amazing firework effect you've ever seen? A perfect weeping willow, a color-changing peony, maybe a massive crackling cloud? Let us know in the comments below. And if you enjoyed this look inside the world of pyrotechnics, be sure to subscribe and hit that notification bell so you don't miss our next trip into the world's most incredible mega factories.